Hello and welcome to SciLux, the podcast where we talk about scientific developments and technological changes in Luxembourg. As usual, we are powered by Research Luxembourg and recording at the studios of RTL City. And in today's show, we have a special guest. So, Julian Wittische is a data analyst at the National Museum of Natural History. Julian holds a PhD in biology, which he obtained at the Université de Montréal. He does research in the field of landscape ecology and genetics with a focus on modeling and simulations. Thank you very much for coming today, Julian.
Hello.
Okay, so as usual, I want to start with definitions and I want to understand ecology because I have a feeling that this was just this word that we used a lot in the past and now it's all about sustainability and biodiversity and we don't talk ecology anymore.
So ecology is often used in a political way, but actually ecology, stricto sensu, is the science of the relationships between organisms and their environment, which includes also interactions between organisms. So it's really the science of how nature works. And you have many, many different kinds of ecology. You can focus on a specific environment, for example, desert ecology, Arctic ecology, aquatic ecology, but you can also focus on human disturbance. You have road ecology. So people study the effect of roads and they're huge. I mean, in some places, they're the driver of mortality in many animals. You can also study agroecology. So applying what we learn from nature to production for agriculture. And you also have subdisciplines of ecology that are more defined by the tools they use. For example, chemical ecology. So how does an insect overcome the chemical defense of a tree, for example? Or even numerical ecology, which is what I focused on. And basically it's just mathematics and informatics applied to ecology. So building tools that other ecologies may use. Finally, there are things that we don't put ecology at the end, but there are still a subfield of ecology. For example, all the interactions between hosts and pathogens when you have parasites, or again, coexistence. The theory, why so many plants which use the same nutrients are able to coexist, species of plants. So this is also a part of ecology. So ecology is very wide.
Very wide. You just opened this huge door for me and I think we could stop here and you would just tell me a little bit more about each field and that would be 40 minutes already, if not a couple of hours.
Yeah, and it's interesting. It's also for a student who comes to ecology, it's also like going to the supermarket. Whoa, I love this. Oh, I love this. Oh, but in the end, when you focus and you specialize, you have to choose, which I try not to do. I try to stay a jack of all trades because I was interested in many sub-disciplines of ecology, but yeah.
So you mentioned numerical ecology and I want to, of course, discuss it in more detail. But before that, I also know that there was something about landscape ecology and I don't understand. So is road ecology part of landscape ecology or not?
So I was waiting for you to mention it. Yes, landscape ecology is my focus. Well, landscape ecology combines elements from spatial ecology, which basically uses spatially explicit methods. Think about space, like space around you, not space, outer space, and classical ecology. So we want to explain phenomena, for example, the diversity of species in a landscape, forest, agriculture, roads. What variables explain this diversity, but in space? Like you take into account that the forest is there, the road is along the forest, whereas before landscape ecology, we just had numbers summarizing the landscape for 1 square kilometer and we didn't think about how the forest was configured, how the edge of the forest was configured. So those things we came to be very important in ecology and so landscape ecology was born. Landscape ecology interacts with many other ecologies, subdisciplines of ecology and other sciences. For example, landscape ecology is very important to understand if you want to understand the population genetics. So basically, how does a gene travel through populations? Of course, maybe a road will kill many animals and this will stop the flow of genes. So it's important to understand this from a population genetics point of view. Also conservation, of course, mortality, I talked about it. Also ecosystem services. How much does this forest capture? How much CO2 does it capture? Epidemiology with COVID, for example, the landscape is very important. So if you have points in the landscape, for example, it's a small street where you have many tourists, it's a pinch point where many people converge. Well, this part of the landscape will lead to more uptake of the disease. So you can relate landscape ecology to many, many questions, and landscape is a unifying concept in ecology because everything can be a landscape. Your tongue right now has many bacteria and they're distributed not randomly. So your tongue is a landscape where different variables drive the distribution of the bacteria. So you can understand many things from a landscape perspective.
Oh, I'm stressed to speak because I have a feeling there is a focus on my tongue, but it was a great example. And I was just thinking, okay, so as a landscape ecologist, do you get on with architects and urbanists or not?
I would say it depends. When we need to house people, it's better to create tall buildings to reduce our impact. But also, for example, to avoid many birds dying, we have to change the glass. Many birds collide into windows of large buildings, and this is an issue. So the people who designed the building should take this into account. So when they do, great. When they don't, well, either they know or they don't, but both cases it's bad for the environment and for the movement of the birds because they die or they're injured. So sometimes we're friends, sometimes not.
And then I have a feeling that I focus maybe on the that side. But then would you say that as a landscape ecologist, you focus more on those environments that are human influenced? Or because you mentioned forest, right? So that would be, okay, it depends on the forest. And I know many are just human created. But in general, the tendency would be, is it the landscape that has been there natural with inverted commas? Or do you mean partially natural and the road, or do you also specialize in one of them, or how does it work?
So I did not specialize in one of them, but you can. So you can be a landscape urban ecologist.
Yay, another term, yes.
So focusing on cities, but I have worked on, let's say, more natural forest, let's say 90% natural landscapes, and I have also focused on heavily disturbed forest both in the west of Canada, both close to the boreal forest. So if you know, it's a forest that links coast to coast Canada. So it's a huge forest. I think it's the second biggest in the world. Don't quote me, I'm not sure, but in the North Hemisphere, I think it's the second one.
Okay, so looking at forests in Luxembourg and looking at forests in Canada.
So yeah, very different scales.
Exactly, totally different scales.
Both are important, I would say, to preserve. But do you understand? In Canada, it's a huge part of its climate too, and of its economy. So, for example, there is a tiny beetle, which has destroyed large part of the forest many, many, many times. 100 Luxembourgs of forests have been destroyed, and this has hugely impacted the economy. More than 1% of the GDP of the province, which is huge. It doesn't sound huge, but it's huge. But also bad because it releases a lot of CO2. So, of course, it's a natural landscape, but if it's exploitable in the future, it's already a loss, even if it's sustainably exploited. So, yeah, complex. Everything, I would say, is influenced by man. Few landscapes have no disturbance nowadays, but I've worked on different landscapes with different scales, different temporal scales, different spatial scales, and different levels of disturbance.
And is it that you're trying to preserve something, or is it you're fighting against certain effects? What's the stance here? Is it more analyzing the state of affairs, or is it trying to, influence decision makers on certain topics?
Both. You have the fundamental question, which stimulates the scientist into you. And of course, when it's heavily disturbed, then people keep destroying the forest there by extracting oil from the ground. Oftentimes from the ground, they dig the ground and they destroy a large. I think it's almost the size of Luxembourg. That is like a big open air mine for oil sands. It's called oil sands because it's a mixture of bitumen, water, and sand. Anyway, so of course it's revolting, and you try to do something, but we are not activists. My study, for example, supported the fact that we have to reclaim different parts of the landscape for the community to have a chance to come back to those very disturbed places, or to come back to its level before. And before, people were mostly focused on reclaiming linear features, which are roads and trails that were created by humans. So basically, you fell trees, you make it harder to go through, and this should, after some time, be not useful for example, predators. The big issue was that the trails were becoming highways for predators, and they were disturbing the dynamics, and they were heavily impacting an endangered type of reindeer, caribou, the Christmas Rudolph. So they're not in good shape there. And in many places in Canada, the forest boreal woodland caribou is in bad shape. Anyway, so by only focusing on those linear features, reclaiming, meaning recovering the land, trying to make it, restore it, it's only part of the solution. I showed that the block elements, for example, where they cut a lot of trees to make space for infrastructure, they also have to reclaim it. Basically, the population of deer grows too much because they eat the grass that grew instead of the trees the human removed. And because there are so many deers, the population of wolves becomes huge. However, the caribou does not benefit from any of this. Actually, they are afraid of roads. They won't come in to eat the grass like the deer do. So you have a huge number of wolves, which also they eat a lot of deer. They also eat caribou. So if the population of wolf increase, the population of caribou will decrease.
So basically,
it's a cascade.
Yes. Do you sleep well at night? This sounds very
No,
bad.
well, working in biodiversity nowadays is a bit like being a doctor during the plague. It's depressing, but someone has to do it.
True.
Someone has to at least document and try to slow down the loss of biodiversity.
So let's imagine a positive outcome, positive scenario. Let's start with that. I probably think we will go into negatives again, but now the positive. You can decide on what people do all over the world. What can we do for biodiversity? Ideal situation.
So I would say eat local, eat less meat. I'm not saying everybody should be vegan, but eat less meat. Stop smoking. Tobacco production, both the plant and its drying, curing, requires lots of wood to be cut and burned, so it's terrible. In some places, tobacco accounts for most of the deforestation. If you want something more local, I would say keep your cat indoor if you can, especially if you live close to a natural reserve, because cats will kill annually much more birds than wind turbines will. I'm not saying they're great, but cats eat amphibians, reptiles, birds, and I love cats, but keeping them indoors also makes sure they're safe. You're less likely to fight and to have diseases. So, of course, old cats who have been outside of all of their life maybe can keep that way for a few more months or years. But if you have a new cat, I beg you to keep it indoors. If you live close to a nature area, it's safer for the cat, it's safer for nature, and it's going to cost less in veterinary cost if you fight or make babies,
True. Okay, I don't have a cat. I don't smoke. I already feel better about myself. I don't eat a lot of meat at all. But I wanted to understand the meat part because we discussed it, CO2 meat, but biodiversity and meat, what's the relationship?
So, for example, a lot of beef comes from Brazil. And to make space for beef, they cut the trees. This is outside of my personal expertise, but it's something we know and we have known for a long time. Even students learn about it quite early. So I'm not saying anyone should drastically change, but if you stop smoking, it's a good point. If you eat less meat, or I would say eat local meat, local organic beef, sure, go ahead. Eat some wild boar that your father or uncle has shot, sure. But eat some Brazilian beef every day, it takes its toll. If everybody would do this, we would need like 3 Earths or something. So
okay, you mentioned hunting, but wait, that's good for biodiversity, hunting?
No, but wild boars are in. I'm not a hunter. I don't encourage people to hunt. But I'd rather someone eat a wild boar that they kill in Luxembourg rather than beef coming from another continent. So we have many wild boars, and we We don't need more boats coming with meat from abroad. So yeah, I'm not against hunters. Hunters can be helpful for some of our studies. For example, they can provide samples if we want to study a disease in fox or wild boar or things. But some hunters also are bad for biodiversity, I would say. In Luxembourg, maybe less so, but in other countries.
A lot of minefields. I can feel that. Tobacco and, hunting and whatever. I don't know where we're going, but it's pretty kind of controversial
those are my
subjects.
personal opinions, of course. And I don't think they're extreme. It's just what we see in the scientific literature.
Very simple. We met at the Researchers' Days, and I have to say that I stayed there a little bit longer at the museum stand because I wanted to listen to you explaining things to people, because you were talking a lot about biodiversity and pollinators. In a second, we're going to ask a question about that. And I was really impressed how to say, patiently you were explaining to some people who had no clue about biodiversity. This is amazing. When I was preparing for this episode today, I was thinking in a way it's important. We need to discuss it. But at the same time, in my bubble, this is discussed on a daily basis. And I'm tired. Sorry, I have to say that. How do you find the patience to again re-explain and just tell people, come on, do this? I don't know. I always see the fauchage tardif that is important. All these plants that we need to kind of reclaim and get back and all that. How do you find the patience for that?
Well, it's hard. But if I can change one person's mind, it's a good day.
You'll go for that. Okay, I teased the pub quiz question, so I think we have to have a look at it right now. So as usual, listeners, remember, after Julian has asked the question, the answer will be only at the end of the podcast, so listen to the whole thing.
How many species of pollinators do you think there are in Luxembourg? Between 100 and 500? Between 500 and 1,000? Or more than 1,000?
Okay, remember the answer only at the end of the podcast. Maybe you know it. You can Google. I always say that, but don't. Continue listening because we have a lot coming that is definitely interesting still to discuss. Okay, we kind of went through biodiversity a little bit. We did the ecology part, at least a little bit. But, I kind of let you into the whole of the landscape ecology. But you actually said, but I am more into numerical ecology. So wait a second. That's together? That's separate? What is that?
Yes. So for example, to analyze the next wave of COVID-19, they use mathematical models which are going to predict when the wave is going to hit. Sometimes they fail, but sometimes they work. And oftentimes they work. They are going to predict the next wave based on the past data, based on the past numbers of people who got it and its cyclicity and many things. I do the same, but for biodiversity. For example, I used complex mathematical models and artificial intelligence to study the movement of the beetle I was talking about that destroyed the forest. What environmental factors influence the capacity of this beetle to move through the landscape? And we found out that altitude and climate were big drivers for this beetle. Unfortunately, with a warming climate, it's going to have less and less difficulty, hindrance to move through the landscape. So, yeah, bad news.
Yes. Again, we're coming back to
I told you
there's got to be again negative. But yeah, that's part of it. Today, I don't think we can be all the time optimistic. But then how do you get data for that? Because I understand COVID, okay, we gathered all the data. But here, what do you go? You measure yourself? Or? So
for the beetle, for example, we extracted its DNA from hundreds of beetles. Hundreds.
You were catching them first? Or?
So people went and sampled them. They go lay eggs in the tree, and so they are associated with specific species of trees, pines. So they collected many of them, and you take their DNA. And how does the DNA informs, for example, about movement? Data. We want to extract data now. Well, genetic data, if you think about it, same for humans, same for all animals and plants. If two populations, like a group of individuals, if two populations are genetically close, that means that they exchange frequently individuals that will reproduce with individuals in the new population. So migrants, if you want. Well, if you have two populations that are not close genetically, but are close geographically, this means that you have a barrier between them. They should be reproducing. They should send individuals, dispersers, explorators, if you want. They should send some individuals to migrate and reproduce with the other one, but they can't. So it means you have a barrier. Sometimes it's obvious, it's a mountain. Sometimes it's not obvious. And that's where the mathematical models will help us go through thousands of hypotheses. So we have many combinations of variables, many ways a variable could influence the movement of those migrants. So yeah, you need an artificial intelligence further helps us by finding patterns that our brain cannot. And sometimes we don't have hypotheses. We don't know what's going on. It's a new environment. It's a new species. We don't know about it. So artificial intelligence helps us exploring through all the possibilities. Basically, that's it.
And it means that you kind of can hypothesize better on the data itself, because I guess you don't manage to gather all the data of the Canadian forests, do you?
There are billions of beetles. Right, just in Alberta, for example, which is a province of Canada. So you can't do this, but genetic data is great because it compounds information over many generations and it's very rich. It's very useful. Other kinds of data, such as some of which we collect at the museum, can be observations. I saw this bird there, and you send it to the museum. Sometimes it's local, amateurs. Sometimes it's us. We go on the field. I love going on the field. I've caught many thousands of flies for a project. I love it. And sometimes it's from citizen science platforms such as iNaturalist or observation.org. And we collect all this data about observation. And for example, we have more than 5 million observation data at the museum for more than 30,000 species, which is a lot. It sounds like a lot, but it's not enough. We have many gaps. We don't have, for example, species that are very common. For example, a crow. Many people will take a photo of it. It's going to go through a citizen science platform and we're going to get many of them. Is it useful? Yes, but we wish we had this for rare species that need protection, and we don't always. So yeah, they're useful, but we have to collect more and more through citizen science projects, through museum projects, through amateurs who, for some, it's their hobby to follow a species year round, a population, and they give us the data, which is great. And our job is to integrate it. And my job as a data analyst is to find, collect, and clean, tidy, organize the data, because data is very messy. If you have to read through a notebook from 50 years ago and to translate this into data that you can use in your analysis, sometimes it takes a lot of time. Of course, analyze data and then write reports. And that's where I can give recommendation for stakeholders, for decision makers. And of course, ideally, after I've done all of this, I make the data I use accessible for other scientists like me, so they can do it again to check if I did something wrong, which we should always do. Everybody can make a mistake, and also for them to use in other projects.
It's interesting you mentioned iNaturalist, because one of the guests quite some time ago was Paul Brown from the museum. And if you listeners are curious to know more, you can always listen to that episode where he describes exactly citizen science projects and everything around iNaturalist. I think there's going to be the City Challenge soon as well, right?
City Nature Challenge, yes.
City Nature Challenge, exactly. That's.
If you Google it, you'll find the dates and how you can join.
Exactly. So, and a small appeal, as usual, just go collect, maybe not crows, as we said, but some
collect everything you see, send us everything. It's great. But it's true that on the 4 million data we have about this, we have more, but about 4 million, more than 50% is birds. Birds are important. Species are protected and they need protection in Luxembourg. But I wish we had this kind of data for maybe some small, uncharismatic insects that also need protection and are very valuable in the community they belong in. So
why people are not really collecting data on insects is because
they are.
Yeah. Okay. Yes. Less. Sorry.
The beautiful bumblebee or the beautiful ladybird or things you're not afraid of. But who is gonna collect pictures of spiders if you're not really into spiders? I love spiders. If I see one in my room, I thank it and I leave it there. Thanks for eating the mosquitoes or whatever. But many people are afraid or not interested because it's not charismatic, or they have a negative opinion, or they're just, not interested in taking a picture, or they're afraid. So, yeah.
I think it's also just difficult to take pictures of insects. I think they are kind of faster or not.
Well, sometimes yes. Some otherflies, for example, are really, they have good eyes. They see you coming. They see you before you see them, and they can be fast if they're eating. But sometimes in the morning, insects will warm up. Think about snakes on a rock, but the same for insects, but on a leaf. And there you can take a picture of them more easily. So it depends. It depends, of course. And we have even less data about parasites. They're animals too, after all. Small parasites. Unicellular. How do you get observation data from this? It's still a valuable part of nature, and they're useful.
But I guess that would have to be a scientist noticing them first.
Binoculars. I've had people with binoculars send me great things that I didn't know. I needed to learn how to identify them because I never heard of them. So, yeah.
So you said, all right, we have all this data, but observations are lacking. Why are observations important in general? Why do you need them?
So many times we want to study the distribution of a species to know how does it fare in the current biodiversity loss, urban infrastructure growing, especially in Luxembourg, and warming climate. So if we have a distribution map 50 years ago and distribution map now, we can see, has it reduced? Has it reduced a lot? Is it in danger? Do we need to protect it as soon as possible? Is it expanding? If it's an invasive species, it's probably expanding. And how fast is it expanding? Is it going to reach some very, very valuable place in Luxembourg? We have great natural reserve. We should have more. It's awesome. But if they're reached by a terrible invasive species, we need to follow its spread. And that's based on observation. With an observation, it's not necessarily a photo. It can be a professional. The professional, he or she saw the animal, for example, and they recorded the date. Is very important. That's how you follow an expansion, for example, or a reduction in size. The localization. So it's very important to record it accurately. In the past, they would write, oh yeah, Luxembourg City. No. No, it's latitude, longitude. You don't have an excuse. We have smartphone and Google Maps, for example, or other. I'm not defending a brand, They give you latitude and longitude if you press, and you can record it that way. So it's very easy. Nowadays, we don't have an excuse. And as a data analyst, I will analyze this, so you better do it. As I said.
Basically, give me good data or just don't.
No, give it, because a lot of data is messy. Sometimes it's missing. What if it's endangered species, but it's missing a date? I don't want to throw out the observation. So I'll try to do detective work and try to find who saw it, ask them if they remember. Sometimes it's like this. Sometimes people mess up. I've seen lions in the middle of the Atlantic.
No.
Did they swim? No. The person put the wrong coordinates.
Okay.
But it can be more subtle than this. Sometimes you have coordinates, but they don't fit. Like I see a very rare species of trees. Everybody's looking for it in the zone, but it's not there. Did they mis-enter the data? No. Actually, they put France, and the software put in the center of France, for example. So that's another issue. It's fascinating, all the messiness you can get with data. It's crazy. That's why you don't get analysis very fast. Sometimes it takes years before you clean the data, you organize it, and it's ready for reporting.
Okay. Just thinking, behind the scenes, I often like to ask my guests this question, like, how does a typical day look like at work? So for you, it's just like you turn on your computer and you analyze data, or...
I say hello to my colleagues.
Oh, that's very nice you do that.
I fetch a glass of water. I sigh.
You close all the doors so the cats don't go out. I guess you don't have cats at the museum.
We don't have cats, but we have a dog.
Okay.
A very beautiful dog who doesn't eat anything aside from, what it's given. It doesn't eat the mice.
It's well trained.
Yes. Anyway, I turn on my computer, and beyond the trivial tasks, I would say I do some programming, like people who program the apps on your phone. Well, I do a little bit of this. I do reading. You have to stay up to date because ecology is recent and it's ever moving, because we don't have it's not like physics where we have a theory. Gravity, we know it exists and it's not going to change. In ecology, paradigm changes are quite frequent and you need to stay up to date or you get lost. You're not going to use the best methods and have the best interpretation, and therefore you won't be as useful for conservation in the end. So,
and I guess it's difficult to find the causation and correlation as well.
Oh yeah, causality is very hard because we are in an emergency given climate change and biodiversity loss. Sometimes we have to be cautious and consider that what we have done is not complete, but it's a good start. And if it gives a direction, we have to follow the direction, because doing something is often better than doing nothing.
That's a good approach. We should finish here because it's again on a positive note, but I don't want to finish yet. I have a few more questions to you, of course. But then that's, you're just there programming and gathering data and all that. But you're at a museum. So where does the exhibition part come into play? Are you also part sometimes?
So I'm not personally part of a team that creates exhibitions, but I've given talks supporting, for example, the Impact exhibition conference. So I gave a talk about the forest insects outbreaks, which was a good experience. I got lots of interesting questions, and I wish we had recorded it, but
next time.
Yeah. So yeah, you can always contribute if you do research, even if I'm not in charge of presenting exhibitions, such as Ben Tui, who also came on this podcast. If you want to check his episode, is interesting.
Yes, definitely. I mean, and especially the exhibition was interesting as well. I went twice. I can repeat it again. But for sure, yes, this is, interesting for me too, to hear, because this common perception is that, museums, it's exhibition. But there's a lot of stuff happening that we can't see, just like your work, for sure. One of the things that I also noticed when I was doing research on the website is that there's a discussion on modern ways of identifying new species. Are you also kind of aware of that? Are you using the modern ways? Is it about this and all these apps you have, or what is it?
So I would say for example, iNaturalist or apps like this, anecdotal positive experiences, for example, they have led to rediscovery of species or discovery of a new species. But most of the time, this is not the case, and it's professional who go on the field and compare with previous species. I would say new ways. For some decades now, genetics have had a larger impact on how we define species. Before that, it was more morphological and based on biogeography hypothesis, but nowadays genetics more, impact on how we describe and when we describe a new species. But that's outside of my expertise, so I prefer not to.
Yes, of course. But it's very interesting, isn't it? That no, you definitely won't. Don't worry. That's my part. Normally, I am the one doing that. For sure, what is interesting to me is that we have to redefine a lot nowadays because of genetics, right? That we just kind of thought, okay, this species is related to that. It's like, oops, it's not. It just looks similar, but it's completely different family.
Well, it oftentimes it's not completely different, but genetics show us that they've been isolated. As I said, you had two populations, you have a barrier between, if you have this for hundreds of years and thousands of years or more, well, the two populations are going to diverge so much that they're not going to be able to reproduce together or unlikely to reproduce together. And this creates new species after a while. But it doesn't require them to look any different. And any pollinators, I talk about pollinators, you have to, for some species to differentiate them, they're different. But the only way we can do it easily is to dissect their genital organs, which is, fun, of course, but it's not easy. You can tell just by looking at it when it's alive.
Why genital organs and not something?
Because they differ, and I told you, the populations in the previous example, they were isolated. Well, some of them have developed, for example, a different shape of genital organs that won't fit when they mate with the other population, and you can't see it from outside. But if you dissect it, you can see it, and that's one way that speciation, so the coming of new species, arises. So by differences in genital sexual behavior or morphology.
You mentioned pollinators. I think that's the moment to go back to the question. Before we start talking too much about genitals, I think we can go back to
for another podcast.
That's for another podcast, yes. So if you can remind our listeners what the question was and then tell us the answer.
So it was, how many species of pollinators are there in Luxembourg? And it was between 100 and 500, between 500 and 1,000, and more than 1,000. And the good answer is more than 1,000. So you probably know about the honeybee. The honeybee is a domestic species, like a cow, if you want. Many, many, many more. And they're all
Wait, did you
important.
compare a bee to a cow?
Yeah. It produces something for humans, and we help it, and we keep them safe, and we give them sometimes supplements or syrup, and we collect their honey. Like we collect milk from cows that were exploiting grass in some area. So that's how I see honeybees. That's why it's not good to have too many beehives. You have a few, fine. Same with cattle or with cows. If you have too many, it's bad for the environment.
So why do we talk so much about the bee and not other pollinators?
Because that's what have been charismatic, and that's what companies have been selling.
Okay, so which pollinators
greenwashing?
Should we talk about Okay, you said more than 1,000, so we have 999 other species of pollinators to talk about.
Yes, so you have about 360 bee species, which is a number I know because I chatted with our specialist, Alexander Weigand, and was a PhD student working on this too. And we have almost 200 species of hoverflies, which are one of the animals I study, and you can recognize them easily because they hover like a helicopter. They change direction like this. I know you can't see the movement I make with my hand, but yeah.
Yeah, it's kind of Tetris movement. It reminded me of Tetris more or less, the kind of blocks.
And you have almost 200, but you have also butterflies, you have some coleoptera, you have some wasps even. So you have many, many different species, and they're all important, and we have to preserve diverse habitats to keep them all in Luxembourg. Otherwise, they will slowly decrease.
And you probably noticed that already, the decrease.
Yeah. For hoverflies, we have seen a 70% decline of their abundance in some habitats we thought were pretty good, but they're not so good because they're surrounded by heavy agriculture, which uses pesticides. I'm not saying we should not use any, just saying we should be more reasonable.
So then we can see the movement that people can't see of the hoverflies.
If you have any nice garden, you will see for hoverflies, so messy with a lot of different wildflowers, or even a normal garden, you will see things that look like bee, but it's a hoverfly.
So it's basically also kind of like a black and yellow.
You have probably 100 species which are black and yellow of hoverflies. Why do they look like bees? To make the predators think they're bees, so that they look tough, they look dangerous, but they're not.
So if ever you find one, take a picture as well. So this way Julian will know where they were. And of course, the GPS coordinates not in the middle of the ocean, but somewhere in Luxembourg, hopefully. Yes. So we can know, maybe they will increase in number, who knows. But for now, I guess this is the moment to say goodbye to you. And thank you so much for all the data and all the details you shared with us today. And yes, hopefully see you soon again.
Thank you very much for having me.
So this is it for today. Thank you for listening. And as usual, don't forget to subscribe, to follow us, to check out what we're writing on Twitter, LinkedIn, Facebook, what we post on Instagram and all the different places. And contact us if you have any comments, questions or suggestions for guests. This was Silax, and my name is Hanna Siemaszko.